Welcome back, engineers. In the previous video, we explored everything about query parameters, real-time implementation, practical use cases, best practices, and even tackled some advanced interview questions with solid solutions. Today, we're shifting gears and diving into a must-know concept for scalable API design, one that ensures your services evolve without breaking existing clients. We're talking about API versioning. What? API versioning means creating different versions of your API so you can make changes or add new features without breaking what's already working for existing users. Why is versioning important? Because your users, apps, websites, or mobile clients depend on your API staying consistent. If you change something suddenly, it can break their entire product. Versioning lets you improve your API gradually while still supporting old users. How do you handle different client capabilities while evolving the same API? Solution: parallel support. Different users may be using different app versions. Some might be on old phones or older systems. Instead of forcing everyone to update at once, you can keep multiple API versions running at the same time. Example: this lets old users continue using what they know while new users get access to new features. How do you phase out older APIs without disrupting active users? Solution: deprecation policy. You can't shut off an old API suddenly. That would break live apps. Instead, use deprecation headers to warn users in advance and give them time to upgrade. Example header. This clearly tells developers, this version will stop working on this date. Please switch to the latest version before then. Now let's get more specific. Let's look at the 5 major strategies used to version APIs, their ideal use cases, and the trade-offs of each. Understanding when and why to use each strategy will help you make the right decision in interviews, system designs, and real production deployments. Which API versioning strategy is easiest to debug and supports browser-based testing naturally? Answer: URI versioning. This is the most common and beginner-friendly approach. The version is placed directly in the path. Example: it's intuitive, works perfectly with tools like Postman or a browser, and is easy to cache and route. That's why it's great for public APIs and documentation. Which versioning method allows easy switching between versions from the client-side UI or configuration? Answer: query parameter versioning. In this method, the version is passed as a query parameter in the request. Example: this allows version switching with a simple change in config or UI code. No need to modify endpoints or headers. It's quick, flexible, and great for internal APIs or experimentation. Which versioning strategy keeps URLs clean and REST compliant by moving versioning to metadata? Answer: header versioning. Here, the version is sent via the accept header instead of the URL. Example: it keeps the URL semantic and RESTful. This is more elegant and better suited for enterprise or version-aware clients, but it does require custom middleware and testing tools that support headers. Which strategy provides the most RESTful approach using media type negotiation, ideal for purists? Answer: content negotiation. This is a variant of header versioning using media types that encode version info. Example: it's considered the most REST compliant and allows your API to evolve without touching the endpoint path. However, it adds complexity and is best used when your consumers support advanced headers. Which versioning method enables you to isolate infrastructure, SSL, or routing per version of your API? Answer: custom domain versioning. Here, the version is part of the domain name itself. Example: it's useful when you want to isolate traffic, SSL certs, infrastructure, or regions per API version. Perfect for large-scale systems, A/B testing, or geo-based rollouts. Understanding versioning isn't just about syntax, it's about strategy. These 5 approaches, URI, query param, header, content negotiation, and custom domain, each offer unique trade-offs. Knowing when to use what separates strong engineers from surface-level candidates. So when you get asked about API versioning, don't stop at "we put it in the path." Explain why that strategy fits the system, how it impacts routing, client compatibility, scalability, and infrastructure decisions. That's how you stand out in system design interviews with deep understanding and real world reasoning. Let's now explore a real world scenario every developer faces at some point: e commerce systems, especially product catalog APIs that are constantly evolving. When your product data model needs to grow, adding new fields like inventory, region specific pricing, or availability, you need to ensure that older clients don't break. Here's how to handle that smartly. How do you introduce richer data structures without breaking existing clients? Solution: version segregation. If you suddenly start returning more fields or nested data, older mobile apps may not know how to handle them, leading to bugs or crashes. So instead, you create a new versioned API with the new structure. Example: this way, clients using V1 continue to work without changes, while newer apps can take full advantage of the richer V2 response format. How do you control which client uses which version during rollout? Solution: client targeting. Instead of switching everyone over at once, you assign different versions to different clients, often through client-side routing or by checking custom headers. Example: this gives you fine-grained control, allowing you to roll out features safely and gradually without breaking anything for users on older app versions. This is how you should approach versioning questions in interviews. Don't stay on the surface. Go deeper by explaining how to support multiple versions in parallel, how to target specific clients during rollouts, and how to deprecate APIs safely without breaking production apps. Support your answers with real life examples like Stripe, Facebook, or an e commerce app. Let's now consider another real world situation: working with a mobile app. In fast moving mobile teams, it's common to restructure response fields, maybe renaming them or nesting them for better flexibility. But here's the problem: old versions of the app may crash or misbehave if their expected fields change. So, how do we handle this? With version isolation and stable contracts. How do you manage structural changes in API responses without breaking older mobile apps? Solution: version isolation. If you change a response format, like renaming name to product name or converting price into an object, older apps expecting the original format will fail. The fix: keep both versions live and route each app version to its corresponding API version. Example: this ensures backward compatibility while unlocking better data structures for new versions. How do you ensure front end teams can safely migrate to the new structure? Solution: contract stability. When API schemas change, front end teams need clear contracts so they know what to expect and can code accordingly. Using version specific typed interfaces or DTO as data transfer objects ensures each version is clearly defined and mapped. Example: with clear contracts, the front end team knows exactly what to expect and can safely consume the correct API version without surprises. This is how you tackle versioning discussions in interviews, by demonstrating not just how to manage changes, but how to protect downstream consumers like front end and mobile teams. Explain how version isolation helps maintain compatibility and how stable data contracts ensure safe migrations. Don't just say we version APIs, show how your strategy minimizes breakage and keeps teams moving fast. Because great engineers don't just ship code, they build systems that evolve safely. We've talked about versioning strategies, real time examples, and advanced interview questions. But to build reliable, long term APIs, you also need to follow best practices, things that protect you from surprises and make your APIs easier to evolve, document, and support. Here are 5 best practices that every serious backend engineer should know. Why should versioning be included even in the first release of an API? Solution: future proofing. Even if it's your very first release, include a version in the path like /API/v1/users. Example: adding a version early prevents you from breaking users when your API evolves later. It shows foresight and planning. How do you represent backward compatible improvements without confusing API consumers? Solution: semantic versioning. Use semantic version numbers like v1.0, v1.1, v2.0 to show whether a change is safe or breaking. Example: this helps developers quickly understand the impact of upgrading. How do you help teams understand which versions are current, deprecated, or sunset? Solution: version roadmap. Document your version lifecycle in Swagger, Postman collections, or API docs. Example: this helps internal and external developers plan migrations and avoid building on outdated versions. How do you minimize client-side issues caused by version upgrades? Solution: non-breaking policy. Never remove or change existing fields in a minor update. Instead, only add optional fields. Example: this ensures upgrades don't silently break front-end or mobile apps. How can an API clearly indicate that a version is deprecated to encourage migration? Solution: deprecation, metadata. Use response headers to signal that an endpoint is going away soon. Example: this gives developers time to upgrade and helps teams plan ahead. These versioning best practices are what differentiate solid engineers from great ones. Anyone can create an API, but only thoughtful engineers design with evolution, safety, and developer experience in mind. So when interviewers ask about versioning, talk about why you include versions from the start, how semantic versioning helps developers, and how roadmaps and deprecation headers build trust with consumers. Show that you don't just write endpoints, you design stable systems that evolve gracefully. In the next video, we'll dive into another critical part of modern REST API design, error handling, how to structure clear, consistent, and meaningful error responses that help API consumers diagnose and fix issues fast. Let's keep building strong. In the next video, we'll dive into another critical part of modern REST API design, error handling, how to structure